Hi folks, today I bring a shift register with the capacity to drive to one VFD. This is a CI type power logic 8-bit shift register from Texas Instruments and support until 50 volts. Please take note also exists another driver only with 16 pins and only support 32 volts. I recommend never connect any power to the pins marked as drain X without the protection of the one RL. Otherwise, the MOSFET active will do a short and burn the IC. The connections are very simple, and on this example I make use of two CIs to control 16 pins from my VFD. Each IC supports 8 grids segments and I organize it as two blocks. The first block, byte H, will be responsible to polarize the segments. The second block, byte L, will be responsible to polarize the grids. I highlight the importance of understanding the sequence of send the bits. If you think at 2 bytes, the first bit of the first byte will be the first on the left, and the last will be the first on the right. Something like this to represent the number 8 at first grid on the right side. It easily modify the lines of the code or the order of the connections to adapt to your VFD. Anyway, I recommend you pay attention when you apply copy and paste on code blocks of different videos, because sometimes it's necessary to revert the way of sending the bit. At some videos I send from the right to the left and the others from the left to right. This is one thing you must take account case you combine different blocks of the code from different videos. The code I create to animate the VFD is a basic clock, using the internal trigger of the Arduino to happen all seconds, and after I proceed to update of the display VFD at dynamic mode, and by this reason you only see two functions inside of the cycle while without any delay, because the refreshing of the VFD happens so fast our eyes cannot see it. I use 3 buttons to set the clock, but you can implement more. Can also apply a compare of the bytes to use a clock as wake up. Returning to our drive, it is the focus of this video, it allows a conversion from 8-bit serial in parallel output. This output, marked as a drain 0 until drain 7, is nothing more of one circuit which forces the output to the GND. Of course, we need this drain have a positive potential to close the circuit. To be possible, we provide this level DC with an array of the resistors of 47K with the common pins connected to our plus 24 volts DC. You can use two associated serial DC-DC converters, one of the plus 24 and the other of the plus 12, to get better bright. We are using a VFD using on the grid segments of the positive voltage. Our drive will force this reference to GND. This means we are working in inverted mode. In the normal situation, our driver provides a positive voltage, but the TPIC6B595 provides a GND. We need to invert the bits before of send it to our drive. I do it with the symbol till applied before of our bytes to be sended. Explaining it other way. We provide plus 24 volts DC to all of our grids and segments through the resistors of the 47 kilo ohms. This means all segments will be on. Now, when I set the drain X to the GND, the grid or the segment will be changed to off because lost the positive potential. The port drain X force it to GND. Is by this reason we need inverted bits before sending it. Our ICs are connected in cascade mode. This means the data coming from the Arduino reach the first IC at the pin number 3 data input or serial input, and after the output serial go to the input of the second IC. The pin G from the both ICs go to the GND through two resistors of the 2.2K. The pin marked as a SRCLR is kept with a high value through a resistor of 2.2K to the 5 volts DC. The pin SRCK coming from the clock of the Arduino, and the pin RCK coming from the strobe from Arduino also. Both pins have a resistor to protect. Okay, it's not necessary, but I suggest apply every time because some wrong connection can burn the port of the Arduino. This small matrix of the keys have implemented 3 keys to control the clock. You can see here the 3 wires coming from the pin 3, 4 and 5 from Arduino, and also you have the common pin connected to the GND. The first button will do the reset of the seconds. The second button increment minutes. And the third button increment the hours. Of course, you can add more buttons and apply other functions you need.